Dear students, in this lecture we will learn about Cramer's rule to solve the system of linear equations. And the previous lecture we have studied that how could we write a system of equations in matrix form. So steps which are followed in Cramer's rule are: we need to write the system in matrix form, that is Ax is equal to b. That is the first step. The second one is we need to find the determinant of this coefficient matrix A. If determinant is 0, then we will say that the solution is not possible, and whenever determinant is not 0, then we will say that the solution of the system is possible. So and that is the step which is very much important to use Cramer rule. We need to find deltas, delta 1, delta 2 and delta 3. Find the following determinants. These are actually determinants. Delta 1 is a determinant, delta 2 is again a determinant, and delta 3 as well. So what is delta 1? We need to replace first column of A by B, by this B. The first column of this A matrix will be replaced by B, so that determinant is actually delta 1. And delta 2 is replace the second column of matrix A by B, so that is delta 2. And delta 3 is actually a determinant in which we replace the third column of A by B. So these are deltas. Whenever you find these deltas, the process is very simple. The Cramer's rule, you need to use Cramer rule to find x1, x2 and x3. X1 will be obtained by 1 by determinant of A into delta 1. X2 will be obtained 1 by determinant of A into delta 2, and x3 will be obtained by 1 by determinant of A into delta 3. So putting these values and obtain the values of x1, x2 and x3. So this is the story for Cramer's rule. Let us start solving an example. Let us say an example. We need to solve the system of these equations, linear equations, by Cramer's rule. 1, 2, 3. There are 3 equations, linear equations, because the powers of x1, x2 and x3 are 1. So these are the equations of linear equations. So first of all, we need to write the system in matrix form. How could we write the system in matrix form? Writing these coefficients and this matrix 7, 3, 1, and again 6, 2, 4, 1, 3 minus 1, 2, and x1, x2, x3, and obviously this side. So this system is in the form Ax is equal to b. Now first of all, we need to find determinant of A matrix. Determinant of A will be obtained, expand by row 1. Try to learn this method. How could we expand a determinant by a specific row? So expand by row 1. So row 1, write the elements and the first row and row 1 outside determinants 7, 6 and 3 along with alternate signs plus, minus, plus, and then 7 multiplied by its cofactor. Exclude this 7, exclude that row and that column which contains 7. So we are left with 2 minus 1 and 4, 2. So that is the cofactor of 7. Similarly, excluding 6, we are left with 3 minus 1, 1, 2, and excluding 3, we are left with 3, 2, 1, 4. So that is determinant. Now from here, that is 2 into 2, 2 into 2 is 4, minus 4 into minus 1 is minus 4. Similarly, 2 into 3 is 6, minus 1 into minus 1 is minus 1, and the last one is 4 into 3 is 12, minus 2 into 1 is 2. Now simplifying to get determinant of A in this fashion, and we see that determinant of A is 44, which is not 0. so solution of the system exists. Remember that if from here determinant of a is 0, then we will say that we cannot find the solution of this system, and that will be the answer of the question. Now as determinant is not 0, so using Crammer's rule we need to find deltas. How could we find deltas? Delta 1 will be obtained by replacing the first column of A by B. That is actually a B matrix, the right hand side matrix, 19, 7 and minus 2. So first column of A is replaced by B, and the rest of the columns are the same as in A. Now expand this determinant, as I told you before, expand by row 1. So write the elements in row 1 outside and multiply it with the cofactor of each matrix. So that is 2 minus 1, 4 and 2. Excluding this 19, excluding that row and that column, we are left with 2 minus 1, 4, 2. So that is the cofactor of 19. Similarly, cofactor of 6, excluding that column which contains 6 and that row which contains 6, we are left with 7 minus 1 minus 2, 2. So that is the cofactor of 6, and similarly 3. Now expanding this determinant, 2 into 2 is 4, minus 4 into minus 1 is minus 4, so that is plus. 7 into 2 is 14, minus 2 into minus 1 is minus 2, plus 3 into that thing. So delta 1 is 176. Now delta 2 is by replace second column of A by B. So that is the second column of A, which we have replaced by B. You see, this B is now in the second column, and the first column and third column are the same as in A. Now expanding this determinant by row 1 as previously discussed. So whenever you expand this determinant, we will get delta 2 in this fashion. So delta 2 is minus 88. Now thirdly, we need to find delta 3. Delta 3 will be obtained by replacing third column of A by B. So you see, this third column of A is replaced by B. You see, this is B, this one. This B is in the first column for delta 1. Now this B is in the second column for delta 2. Now that B is in the third column for delta 3, and these two columns are the same as in A. Now again expanding this determinant by row 1 as discussed previously. So whenever you expand this determinant by row 1, so 7, 6 and 19 will be written outside determinants, and exclude this 7 from here. We are left with 2, 7, 4 minus 2. Excluding 6, we are left with 3, 7, 1 minus 2, and excluding 19, we are left with 3, 2, 1 and 4. Now expanding this determinant, 2 into minus 2 is minus 4, minus 4 minus 4 into 2 is 28, and so on and so on. So this is delta 3, which is 44. That is delta 3. So we have obtained delta 1, delta 2 and delta 3. Now we need to use Crammer's rule to find x1, x2 and x3. So x1 is 1 by determinant of A into delta 1. So 1 by determinant of A, we have obtained the value of determinant of A 44. So determinant of A is 44, and delta 1 is 176. You see, this is delta 1, 176 from here. So 44 and 44, 4s are 176, cancelling these two. So x1 is 4. Similarly, x2 is 1 by determinant of A into delta 2, 1 by determinant of A into delta 2. This is delta 2, minus 88. This is delta 2. So replacing delta 2 and cancelling out these two, so we'll get minus 2. Similarly, x3 is 1 by determinant of A into delta 3, 1 by 44 into delta 3 is 44. So that is 44. So replacing delta 3 by 44 and cancelling these two to get 1. So x1 is 4, x2 is minus 2, and x3 is 1. So this is the whole story about Cramer's rule.